Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
And welcome to episode 133 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. I'm Tim Robertson, the host of the Observer's Notebook and also the coordinator of the training program within the ALPO. Thanks for downloading and listening. The ALPO collects and analyzes observations of various solar system bodies and associated phenomenon and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers. This podcast depends upon donations from you, our listeners, to keep it working. If you enjoy what you hear on the podcast, you can donate to it via Patreon by giving as little as $1 a month. If you feel even more generous, for $5, you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can help us out by going to www.patreon.com/observersnotebook. And if you'd like to join the ALPO, membership begins at only $18 a year. For more information, go to www.alpo-astronomy.org. And we are also on the Facebook. Just search for ALPO Astronomy. And yes, this podcast also has a Facebook page as well. Just search for Observer's Notebook. And if you enjoy what you hear on the podcast, please subscribe. That way you'll miss another episode. And now, to kick off the new year, we bring on Carl Hergenrother, our comets expert, and he's going to talk about all the comets coming up and one that's possibly in the sky right now. Enjoy. All right, I'd like to welcome everybody back to this special edition of the Observer's Notebook podcast. We're very happy today to have the executive director of the ALPO and our coordinator of the Comet Section, Carl Hergenrother. Welcome back to the podcast, Carl.
Thanks, Tim. I think this is the 11th one I'm doing.
I think it is. And I got to tell you, all the Comet ones are always the most popular. When I look at the downloads, it's just crazy how people like hearing about the comets coming in the next year. So.
Oh, what's great too is as you go through the years, you can see the number of downloads, going up year after year after year. So it's great to see the Observer's Notebook becoming more and more popular as time goes on.
It's a lot of fun. But before we get into talking comets, you were recently became the executive director of the ALPO. Congratulations on that, or condolences, whatever you want. But why don't you talk about the future of the ALPO in your mind? What do you see happening?
So this is actually the 75th. Next year will be the 75th anniversary of the ALPO, which is quite amazing. And I've been a member of the ALPO since I think around 1990. I was in high school when I first joined. And there were a few years there where I kind of let my membership lapse, but I've been pretty solidly a member for about the last 15, 20 years. And so there's a few of us who sit on the ALPO board. We kind of rotate through the various positions, of which one is the executive director. So I have a 2-year term, which started just a few months ago at the annual meeting. And really, what I see is just trying to get the message of the ALPO out there, trying to not only increase our membership, but also to increase the number of contributions. And I don't mean that necessarily financial, but I mean the observation contributions, people who actually make observations, submit them to the various sections. And some of the ways we're looking to do that is one, we're actually already in a massive redesign of our webpage. If you go onto the webpage, it's been around for a couple years and it's gone through a few iterations, but this latest iteration is a couple years old. So we want to basically upgrade the webpage, make it much more dynamic, make it a place where you want to go to every day, not only to look up new news, new events that are happening in the sky, new calls for observations, but also as the go-to source for beginners who want to learn more about these objects and learn more about how to observe these objects and how they can actually contribute to the science and to the ALPO itself.
Yeah, I'm on the board with that, and it's exciting to see where the website is going. It's been pretty stagnant for a number of years, so it's nice to see that.
Yeah, and the key is just to constantly have new content. So it is a place where you want to click on it. Maybe you don't have to go every day, but at least once a week you might want to go on there and see what's new and what's up.
Okay. Anything else you'd like to share about the future of the ALPO before we get into it?
I mean, another thing I'd like to see, and one thing we are working on, is we've got all these observations. I mean, some of these, like I said, the ALPO goes back 75 years. For example, the Comets section isn't quite that old. It goes back to the late 50s. But a lot of these sections we've got tens of thousands of observations. And a lot of them, were from the pre-digital, pre-internet age. So they're drawings or they're photographs. And I would like to see as many of that digitized and put online. That way they're accessible to everybody. Not only to help future researchers, but also just, it's kind of cool to go back through I've got the Comet archives here and go find like my original letter that I wrote to Don Machholz back in the day, back in 1990, as a little 16-year-old saying, hey, I want to observe comets.
Oh, very cool. Very cool. All right. So let's talk about, let's not get into comets of 2022 yet. Let's talk about what's going on right now in the sky with comets.
Yeah. So 2021 was kind of a slowish year for comets. I mean, 2020 was a great year. I mean, we had Neowise. I wouldn't necessarily call it a great comet, but it was definitely a really, really good comet.
Right.
We got up to about first magnitude, had an awesome tail, wonderful images. And then there were a few other comets in 2020 that got up fairly bright, some of which made the news and kind of fizzled out, but there was a lot of things to look at. 2021 was a little slower. In fact, the brightest comet of 2021 is observable right now, but it's only going to be observable for another day or two, easily in the morning sky. And this is Comet Leonard, C2021 A1 Leonard. This was a comet that was discovered back in January, literally up the road from my house. I live right off the same road that eventually goes up past the Catalina Sky Survey telescopes up in the mountains here north of Tucson.
Let me just back up for a minute. We're recording this in early December, about December 8th. So this is going to be uploaded in about a week. So
okay, so we'll probably have missed the best of Leonard by the time this comes out, which is okay. So yeah, Leonard was discovered back in January. It was 19th magnitude. It's kind of a temperamental comet. There are observations going back into early 2020 before it was recognized as a comet. So we call these pre-discovery observations. And it was brightening really rapidly. And then from about January to about July of 2020, it didn't brighten at all. Intrinsically, if you corrected for the change in distance from the sun and change in distance from the Earth, it was flatlining. And then starting July through about mid-November, it was brightening like crazy again. And then all of a sudden, mid-November happened and the comet just started fading. Now, it appears brighter in the sky because the comet's getting much closer to the Earth.
Right.
In fact, it's going to have a close approach with the Earth in a few days at 0.23 AU. Actually, December 12th to be exact. And also, it's going to be passing between the Earth and the sun. So the phase angle, which is the sun object Earth angle, actually will get very, very high. And so what happens at those high phase angles is you have a lot of what we call forward scattering by dust. If you've ever looked at like a slide projector, a presenter projector, or even just a beam of sunlight shining through a window, you'll notice that when you're kind of looking roughly in the same direction as this light source, whether it's the light bulb or the sun, you see a lot more dust floating through the beam. That's forward scattering. Okay. The same thing happens with dust and comets. And so that should actually increase the comet's brightness as well. But the fact that intrinsically the comet has been fading by about 2 magnitudes or so since mid-November means it's not getting anywhere near as bright as we were hoping. Right. And right now it's about magnitude, I'd say about 5.5. Unfortunately,
I saw reports this morning that it was naked eye visibility barely.
Yeah, if you lived in a very, very dark site, you could see it naked eye. I live in a site where the limiting magnitude is about 6.2, 6.3, and I couldn't see it naked eye.
Okay.
Because remember, even if it's magnitude 5.5, that does not mean it's as bright or as easily visible as a magnitude 5.5 star.
True.
Because the comet is spread out over, in this case, it's spread out over from 10 to 30 arc minutes. depending on how dark your sight is and how much of the coma you can see. So it's fairly diffuse. But yeah, if you're at a really, really dark site, you may be able to see it with naked eye.
Okay.
Right now, the comet is screaming towards the sun because it's going to more or less pass between the Earth and the sun in the next couple of days. And it does show, I mean, the fact that the comet's been fading and there are these morphological features in the coma, these kind of what we call angel wings or arclets, these two kind of looks like jets, but they're going out on both sides of the nucleus perpendicular to the direction from the sun. And these quite often do show up when a comet is splitting or breaking up. Doesn't mean it is, but it does happen quite often when comets are breaking up.
Okay.
And that could be anything as simple as, well, it's just splitting, pieces are falling off. I mean, Hyakutake showed these events. In fact, that was the first comet where it was really well studied. And as we all know, Hyakutake didn't break up.
Mm-hmm.
That was a wonderful, great comet. But then we have seen it with comets like Ison, which definitely broke up. And a few of the more recent comets like Atlas, 2019 Y4 back in 2020. There's a comet that a few of us semi-old timers may remember back in 1990 called Comet Austin, which when it was discovered was predicted to be a potential great comet. In fact, I remember getting my Sky and Telescope where it was obvious they kind of, as it was going to press, they added a little teaser on the front cover saying, monster comet coming. And Austin kind of did something similar to what we're seeing here with Leonard, in that it brightened at a good rate. And then about a month or so before perihelion, it actually started fading. So it was still a very nice fourth magnitude comet, but it never got as bright as it could. And I wonder if that's what Leonard's going through. Not that the comet is disintegrating or breaking up, which is still possible, but that the comet's just, for whatever reason, maybe it's a fresh new comet, the fresh ices, the really volatile ices on the surface have completely burnt off. And now the comet's just settling down to what it's, I guess you would say its more normal activity level will be going forward. But Leonard itself is a morning object. Right now it's kind of between Corona Borealis, and Arcturus, rapidly dropping towards the sun. So in a few days, we won't see it in the morning sky anymore. It'll pass within about 13 degrees from the sun. Unfortunately, if it's only about, even with, forward scattering from dust, even if it's only about fourth magnitude, that's probably much too faint to be seen, even with, optical aid. And then it'll pop up in the evening sky starting in a couple days, where it'll be a little better observable from the southern hemisphere. Here in the northern hemisphere, it'll be a horizon hugger. Okay. It'll pass actually about 5 degrees south of Venus in about a week, because it actually comes very close to Venus physically, about 0.02 AU. And then, but if it continues to intrinsically fade as it's moving away, it should just get fainter and fainter. And so in 2020, it'll still be observable, but it'll only be a southern object by that time, southern hemisphere object. And if this fade continues, it may start the year around magnitude 8 and be as faint as 12 or fainter by early February.
Oh, wow. Okay.
Yeah.
Okay. So get out there and look at it now.
Get out there and look at it now. Yeah. And if you're like me, where we've got, as well as you, Tim, we've got storms, finally getting some rain here in Southern California and Arizona. Yeah, we may have seen the last of Leonard, us personally.
I'm heading to Borrego Springs on Thursday for a week. So hopefully, with the clear skies there, hopefully I'll be able to get a glimpse of it, and also the Geminids. Yeah.
Looking forward to the Geminids this year too.
Yep.
So yeah, Leonard is the brightest comet of 2021 at magnitude 6. Maybe it'll get up to 4 or 5 when it's all said and done. There have been a few other comets that have been brighter in about magnitude 10. A few of which we're going to talk about in the comets of 2022, because they will continue to be observable in 2022.
Okay.
But even with the lack of very bright comets this year, there's been a lot of activity in the Comets section. 81 observations of 81 different comets were observed and submitted to the section.
Oh, wow.
That's about over 750 magnitude estimates and over 500 images.
Fantastic.
So we've been actually getting quite a bit of activity.
Good. All right. So let's get into 2022.
So 2022. So a few of the comets, in fact, there's there's probably going to be about 7 comets that we think are going to get brighter than magnitude 10.
Okay.
And of these 7, 4 of them were discussed in the Comets of 2021 podcast. So these are comets that are already observable, already bright, visually observable, and reasonably small backyard equipment, and are going to carry over into 2022, and in some cases become even brighter in 2022.
Okay.
So we already talked about Leonard. Another comet is a long period comet called C2019 L3 Atlas. Now, Atlas is one of the NASA-funded all-sky asteroid surveys. In particular, this is a survey that has telescopes on the mountains in Hawaii, and it's really looking for objects that are kind of on a impact trajectory with the Earth, like something that might only be a few weeks, a few months out. But they're really good at discovering comets, and in fact, they've already discovered 59 different comets just in the past 5 years or so that they've been active. Now, this 2019 L3 comet was discovered in June of 2019 back at 18th magnitude. And it's already up to around magnitude 9. It starts the year near opposition, where it currently is as well. And perihelion is on January 9th. So it's getting as close to the sun as it can get here at the beginning of the year. But one thing about it is it actually is a fairly distant comet. Unlike, say, Leonard, which is getting down to about 0.62 AU from the sun, so well within not only the Earth's distance, but even within Venus's distance. L3 Atlas, its perihelion is only at 3.6 AU.
Oh my.
So it's kind of halfway between Mars and Jupiter. So it's coming to a perihelion kind of smack dab in the middle of the asteroid belt there. And so it'll be at its best for the first 2 months of the year, January, February, where it'll peak maybe around magnitude 8-ish, about magnitude 9. So not much brighter than it's at right now. But because it's got such a distant perihelion distance, the changes in the distance between the Earth and the changes in distance between the comet and the sun are pretty slow. So the comet may actually turn out to be a very slow fader and may be observable in small backyard equipment through the rest of the year. It may still be as bright as magnitude 10 as late as May. Here in the Northern Hemisphere, we kind of lose sight of it in the summertime in June, and in the Summer Hemisphere in their winter in July, just because it gets too close to the sun. But it'll reappear after going through solar conjunction in August and September for both hemispheres. And it could still be a magnitude 11 object at the end of the year. So L3 Atlas may be one that may be around for quite a while. The next 2 comets on the list are both short period comets. And again, they were comets that were discussed in the last Comets of 2021 podcast. One is 67P Churyumov-Gerasimenko.
I'm glad you said that, not me.
Yeah. And I'm not 100% sure I'm even pronouncing that right. But we all know this comet because this was the comet that the Rosetta mission went to. Rosetta was a European Space Agency mission that went to 67P back about 5-6 years ago, dropped a lander on the surface, went into orbit around the nucleus. This is the nucleus that kind of looks like a rubber ducky. Mm-hmm. And eventually the main spacecraft itself was kind of soft crashed, you could say, on the surface after its mission was over. So this is probably the comet that we know the most about because you had a spacecraft that was orbiting it for a couple of years there. And it's fairly large, about 4 or 5 kilometers across. That's pretty large for a comet, especially for a short period comet. 12-hour rotation period. Cool thing about comets is how their density works out. 67P has a density of 0.5 grams per cubic centimeter. That's half as dense as water. So if you had a big enough lake and dropped 67P in the middle of it, it would definitely float.
Wow.
Kind of like Saturn mostly floats. I mean, but this would just be boom. You could use this as a life preserver.
So it's basically a frozen snowball.
Yes, exactly. And so 67P was discovered back in 1969. It was a photographic discovery from an observatory that's in Crimea, from 2 astronomers who were originally in the Alma-Ata Observatory, which was then the Soviet Union, but is now in Kazakhstan. And this was an object that wasn't especially bright when it was discovered and actually had a perihelion distance that had just been kicked in. And it's currently having its best possible return. It's having the closest approach to the Earth that we've been able to model going out at least 100 years. it won't have a better return going for the next 100 years. So there will be returns that are not that much worse, but it's having a pretty good apparition. And again, for some of the old time observers, you may remember observing this one back in 1982 when it had an apparition that was a little bit worse than the one here. And it got up to about 8/9 magnitude. So for this apparition, perihelion was back in November at 1.2 AU. And so the comet starts near its peak and it's near opposition at around magnitude 8.5, magnitude 9. In fact, it's located not that far in the sky from the previous comet we talked about, which was L3 Atlas. And as the year goes on, it'll slowly fade. So we should expect it to fade from around its magnitude 8.5 or so that it's at now, to magnitude 10 in early February and down to 12 in early March.
Okay.
And then the next one is another short period comet, 19P Borrelli. Mm-hmm. Now, this comet was also visited by a spacecraft. The Deep Space One mission, which is a mission that most people probably don't even remember. It was more of a technology testbed mission that was launched back in the late 90s. And it passed by Borrelli. It was a flyby mission, unlike Rosetta, which actually orbited 67P. And Borrelli is a little bit kind of a famous shape. It didn't look like a rubber ducky. It looked like a bowling pin. So again, similar 67P, you had what's probably two pieces of a nucleus kind of glued together. There's, discussions as to whether that means these were two pieces that came together, or do you just kind of have erosion over time, and maybe the neck is the part that's attaching these two. And as the comet's active and goes around the sun and they got sublimation, it's starting to like differentially erode away in that section. Or maybe it was pieces that came together, formed a much larger object, and then after multiple breakups and erosion, you're just seeing the individual components now breaking apart. But Borrelli is actually similar size, even though it's longer, it's narrower than 67P, but it's roughly the same mass, same amount of material in the nucleus as 67P. But it actually has an even lower density of only 0.3. So it would make an even better life preserver than 67P. And Borrelli was a visual discovery back in 1905 by Alphonse Borrelli, who discovered 10 objects visually. This is its 16th observed return. Even though the comet is around magnitude 10 now, it will continue to get brighter over the next 2 months because perihelion won't be till February 1st at about 1.3 AU. And so it should be at its peak in January, February, around magnitude 9.
Okay. Now, is this an evening object?
It currently is an evening object.
Okay.
Borrelli has a somewhat high inclination for a short period comet. So it starts each apparition as predominantly a southern hemisphere object. And now it is racing north and becoming more of a northern hemisphere object. And so once we get into 2022, it'll be observable from both hemispheres. And as we start getting a little later, into February, it's a much better place for the northern hemisphere and gets a little more difficult for the southern hemisphere.
Okay.
Now, the next comet I want to talk about is one that may or may not get bright. And this is C-2021-03 Pan-STARRS. And this object was discovered back in July. Pan-STARRS has 2 telescopes. Similar to Atlas, it also has 2 telescopes. And both these telescopes are in Hawaii. Though Atlas is building more telescopes around the world, including some in South Africa. So they are spreading into the southern hemisphere. But this 03 Pan-STARRS comet comes to perihelion on April 21st at a very close distance of 0.29 AU. Now, it suffers from a lot of the same observational constraints or issues that Leonard has, where it will be extremely close to the sun when it's at its brightest. From the northern hemisphere, we'll be able to watch it come in up to maybe a week or so before perihelion when it gets too close to the sun, kind of like what Leonard is doing. And on perihelion, it'll only be 16 degrees from the sun. Now, the problem with 03 Pan-STARRS is that it was 19th magnitude, was discovered back in July. So here we are now, 5-6 months later, it's only 17th magnitude. This is yet again another comet that just will not brighten for whatever reason. Maybe it'll experience what Leonard experienced, and it'll, enter a phase of rapid brightening. And if that's the case, then maybe we could be talking about a comet that might be 7th, 8th magnitude around perihelion. But the fact that, a comet looks like it's faint and it's poorly placed close to the sun, will make this a very difficult object to observe. After perihelion, it does move away from the sun and does move pretty quickly north, so it does become circumpolar by mid-May. But yeah, this is one that we'll have to see. It is a dynamically new comet, which means it looks like it is making its first, close approach to the sun. These comets do have a tendency to not survive. Not only not survive perihelion, sometimes not even survive up to perihelion. So whether or not this object becomes bright or not, it is an interesting one to at least image and watch visually if it does get bright enough, because this could be yet another one of these disintegrating comets. So it'll be interesting to look at.
Now, is this its first time through, or?
It looks like it is based on the orbit. Yeah.
Right.
Yeah.
So we have no idea how it's going to react when it gets close to the sun.
We have no idea. But the fact that it has not brightened in the last couple of months, that also sometimes seems to be a telltale sign of comets that either disintegrate or, like Leonard, are going to start showing some fading trends as they get close to perihelion.
Okay.
Yep. We got 2 more comets on the list. One is a comet that we are going to hear about a lot for the next 2 years because it's pretty bright. I shouldn't say it's pretty bright, but it will stay reasonably bright for quite a long time. And this is C2017K2 Pan-STARRS.
Another Pan-STARRS.
Yeah, Pan-STARRS has discovered 261 comets, so they've got a lot. This comet was discovered as, 2017, so back in May of 2017, when it was 16 AU out. Okay, so you're talking between the orbits of Saturn and Uranus. Pre-discovery observations were found back to 2013 when it was 24 AU out. So now we're talking just beyond Uranus. Perihelion is until the end of 2022 on December 19th, when it'll be at 1.8 AU. The comet has been, even though it's a dynamically new comet, so it's kind of, may have the same problem as Pan-STARRS, previous comet, the other Pan-STARRS. It's been brightening steadily, slow rate, but at least steadily since discovery. And so right now the comet's around magnitude 11, and that's where it'll start 2022. Though it is a northern hemisphere object, it is slowly moving south, so the southern hemisphere observers should be able to pick it up by February. It goes through opposition in June. Unfortunately, as it moves south, we're going to lose it here in the northern hemisphere by September, though at that time it'll be around magnitude 7. And by the end of the year, the comet should be about a 6th, 7th magnitude object in the evening sky, though it'll only be observable from the southern hemisphere at that time.
Okay.
But that's a comet that, already there are visual observations of, and a lot of nice CCD and CMOS images of, and we'll continue to observe it through 2022, well into 2023 and beyond.
Okay, now is this a short period, long period comet? What is?
This is long period. So it's a dynamically new long period comet. So it's making what we think is its first close approach.
Okay.
To the sun. And then the last comet on the list is C2020 V2 ZTF.
What is that?
Exactly. So the C means long period. If it were a short period, it would be a P. Of course, 2020 is the year it's discovered. V means what mid-month it was discovered in. So V is the first half of November. The 2 means it was the second comet, not necessarily discovered, but the second comet designated or formally announced during the first half of November. And ZTF, like Pan-STARRS, like Atlas, is the name of an asteroid survey.
Okay, I've not heard of that one before.
Yeah. So in this case, it's the Zwicky Transient Facility.
Okay.
So this is a group that's got using a mosaic CCD camera on the 1.2 meter Schmidt on Mount Palomar, which was the same Schmidt that was being used for years for, the Palomar Sky Survey.
Okay. That's where the Zwicky came from. Okay.
Yeah, exactly.
All right.
And of course, they're discovering lots of supernova, just like Zwicky used to do. And so these comets are called ZTF. In the past, sometimes they're called Palomar as well. But I think they've decided, and sometimes they actually are named after the name of the observer. But I think going forward, they will be called ZTF.
Okay.
So this is Comet ZTF.
Okay.
And I'm not sure why they don't just call them Comet Zwicky, probably because that is the name of an actual astronomer. So it'd be confusing, I guess, if you were naming it after someone and that happened to be the name of the survey rather than the name of the astronomer. But yeah, this V2 was discovered back in November 2020 at 19th magnitude. Similar to 2019 L3 Atlas, it's a long period comet, but with a distant perihelion distance. Not 3.6 AU, but one at 2.23 AU.
Okay.
And perihelion won't be till May of 2023. So again, this was a comet that was discovered pretty far out, over 8 AU from the sun at discovery. And it'll start 2022 at a pretty faint 15th magnitude, which is definitely fainter than most people can get visually. Not all, but most. And it will only be a northern hemisphere object this year, and will actually be a northern circumpolar object during the last few months of the year. But if it continues brightening the way it has been, it could be as bright as magnitude 12 by October, around magnitude 10 by December, and that'll eventually peak at around magnitude 9 for the first couple months of 2023.
Okay.
And for those in the southern hemisphere, starting in May 2023, it'll be observable from the southern hemisphere, when it should still be at least around 10th magnitude.
All right.
So those are all the objects that we think are going to get brighter than about magnitude 10.
All right.
There are 3 other objects I just want to quickly call out. C2021 E3 ZTF, again, Zwicky Transient Facility Discovery, comes to perihelion in June at 1.78 AU and is only a southern hemisphere object. There's C2021 P4 Atlas, perihelion at the end of July at a pretty close 1.08 AU, though unfortunately it's going to be on the other side of the sun, so it's going to be at a very low elongation at the time. And this one is observable from the northern hemisphere before perihelion, won't be observable during perihelion because it's close to the sun, but then the southern hemisphere can pick it up after perihelion, though it will be a horizon hugger for them. And then C2021 T2 Foals, and Carson Foals is another, like Greg Leonard, who discovered A1 Leonard, is another Catalina Sky Survey observer. And this object comes to perihelion in June at 1.26 AU, but it's only going to be a southern hemisphere object when it's bright. And all 3 of these objects are only predicted to get around maybe a magnitude 11 or 12, but they're far enough out that maybe if they brighten quicker than expected, they could actually become significantly brighter, at least brighter than 10th magnitude, and could be nice, small aperture objects. And then, of course, there'll always be new objects. It seems like every time I do one of these podcasts,
Yep.
Like the comets of 2020, then all of a sudden we had Y1 discovered, Y4 discovered. A few months later, you had, of course, NEOWISE, right, and then F8 Swan. And then the most recent one, the comets of 2021, and Leonard was discovered only a month later. So it always seems like, for whatever reason, December, January, we seem to find next year's good comets.
Oh, good. Good. I hope that happens this time.
Yeah, I hope so too.
Yeah. And if it does, you'll definitely come back on and talk about those.
Oh, definitely.
Yeah. Now, you talked about the ALPO website, that you have your comet section on there, where you have a comet blog where you talk about the various and that's updated pretty regularly, right?
Yeah, that's a monthly thing that I put out.
Okay.
You can get access to the PDF through the ALPO website if you go to the Comets section link. Okay. But I also post a little bit of a truncated version. Really, it's all the text, most of the text, without a lot of the images. And I put that on Cloudy Nights.
Oh, really?
So if you do a search on Cloudy Nights, just ALPO Comet News, you will find forums for each month. And I put out these, what I call Comet News, every month. Okay. So you'll find them there. And of course, you can chat and talk with other people about comets.
Cloudy Nights is a great resource.
Oh, yeah.
It really is. Okay, I'll put links to both those, though, in the show notes so people can access them from this podcast as well.
Mm-hmm. Sounds good.
Yeah. So you have anything else you want to share?
And if you want to contact me, of course, you can go to the Cloudy Nights forum. You find me there. I'm the one posting stuff. You can also find my link on alpoastronomy.org, which is our website. But you can email me directly at comets. That's comets, plural. Comets at alpo-astronomy.org.
Sounds good. All right, Carl. Well, you have a great New Year's.
Thanks, you too. Yeah, happy holidays.
And clear skies, and hopefully we get some fairly bright comets in the coming year.
I hope so. I've got all my stuff ready to go. I just need something.
I hear you. All right, we'll talk to you later.
Okay, thanks.
Well, that'll do it for this episode of the Observer's Notebook podcast. I again want to thank Carl Hergenrother for coming on again and talking about comets. Hope you enjoyed it, and let's get some bright comets in the sky for 2022. We upload new episodes of the Observer's Notebook every few weeks. You can subscribe to us on iTunes. If you do, please rate and review us. I really would appreciate that. You can also listen to us on Apple Radio, iHeartRadio, Soundcloud, Spreaker, Google Play, Stitcher, Amazon Echo, and Spotify. If you want to support the podcast, you can do it via Patreon. You can give up to $35 a month, where you will receive 1 year's membership to the ALPO and producer credits on the podcast. And with that, I want to thank the continued producers of this podcast, Steve Siedentop and Michael Moyer, for their generous support. The link for Patreon, as well as the link for the ALPO, is in the show notes. If you'd like to talk to me via email, you can get a hold of me at cometman@cometman.net or on Twitter at @ObserversNBPod. Until next time, my hope is that you always have clear and steady skies. Thanks for listening.